Hi, my name is Daniel, and this is the second episode of the Spelunky PSP development series. Watch the previous episode to get to know how I set up the project and wrote a cross-platform tile renderer. This time I changed the formula a little bit and summarized the episode firstly to then share the implementation details. I hardly know from where should I start, since changes are really radical, but what's most important, I implemented the main dude and used the state pattern to wire it together in a maintainable way. The main dude is now controllable and he can walk, he can duck, he can crawl, he can throw things, he can jump, and he can even push walls. I changed the main menu layout a little bit so it would fit to the 16:9 screen aspect ratio of the PSP. And now let's enter the game level. The main dude can hang off the cliffs, let me do that again. I also implemented the HUD, so to render the amount of equipment the main dude has. That involved implementing screen space camera and a font renderer. Main dude can now climb ladders. Again, climbing ladders. The hanging of cliffs behavior is quite bugged right now and it sometimes prevents from jumping over obstacles. Let's now proceed to the level summary screen through the exit. The level summary screen is normally a place where I would utilize a font renderer and draw the amount of loot and equipment and whatever that has happened during the last level. And this is quite embarrassing. Again, hanging of cliff behavior. And notice the shop. The shop in the future will contain a shopkeeper and some items to buy, like in the original game. The levels right now seem quite abandoned without all the loot and NPCs. Again, the level summary screen. The levels are generated using the generator from my previous project, which is Spelunky NDS. Notice how the background darkens when the camera moves. I think it has something to do with vertical synchronization or double buffering, and I guess that migration to SDL2 would solve the problem. But this is another thing to do in the future. And again, hanging off cliff behavior will prevent me from exiting the level. This really needs some attention. But this is not everything. Remember when I said that by using CMake, C++14 and a rudimentary subset of OpenGL, Spelunky PSP could be run pretty much on every device? Well, just to prove that the statement stays true, I tried building and running Spelunky PSP on a Raspberry Pi from the very same codebase I use on Linux and PSP. Raspberry Pi 3 has 64-bit quad-core ARM processor and a gigabyte of RAM. It can run Quake 3 and Minecraft on minimal details, and hell, it can even emulate PSP when it comes to some less intensive titles, so it is definitely as powerful, if not more, than the PSP. I didn't build a toolchain for cross-compiling as this was only a one-time stance, so the painfully long build proceeded on the Raspberry itself. After installing Git, GCC, CMake and pre-built SDL 1.2.15, absolutely no changes were required to build and it worked in 60 FPS. Raspberry Pi 3 is pretty powerful after all, so let's find some less impressive device. Here is an Orange Pi 1. Manufacturer claims that it has 512 MB of RAM and Mali 400 MP2 as a GPU, which, as I found out, is the same chip as on a number of phone models from HTC Desire 310 that originated in 2014 to Samsung Galaxy Tab A7 from 2016. For 60 FPS, I had to limit the resolution to the one I use on the PSP, which is 480 by 272. So as for now, Spelunky PSP support Linux-based platforms and obviously PSP, but those are not my last words, and with some minor changes in the CMake files, my friend Rafał added Windows support. Those are good news because even though I prefer CLion and Linux as a development platform, Visual Studio ships CPU, GPU and memory profilers that will be useful in finding bottlenecks and memory leaks. As an example, let's have a look at this memory profiler. Let's enter a level and take a memory snapshot. As you see, it already reached around 50 megabytes of allocated memory. This is including system libraries. Let's stop collection. Then click a few buttons. This takes a while. And as you see, sorting by size, the biggest allocation so far is those 86 kilobytes which happen in batch vertices function in the level class. So those 86 kilobytes are actually storing a mesh. This is how fast it takes in the Visual Studio Memory Profiler. To describe what the state pattern is, I'll use a quote from the game Programming Patterns by Robert Nystrom. This is a book that I very much recommend because I use a variety of patterns that are described here. To name a few, it would be a singleton pattern, although it is not very much recommended in most of the cases, the component pattern, the state pattern that we are talking about right now, the data locality, the dirty flag, spatial partitioning, the update method, the game loop pattern. It is basically a list of blueprints that you can use in your own projects. And the quote I am referencing is, "To allow an object to alter its behavior when its internal state changes, the object will appear to change its class." It very much explains what the state pattern is, but what will explain better is an example using source code. Just to show you the scale of the potential mess that I am dealing with, let's list every potential state that the main dude can be in. So let's start from standing, running, walking, ducking, crawling, jumping. If you can jump, you can also fall. Pushing a wall, throwing something, climbing a ladder, hanging off cliff, exiting a level, being dead, and being stunned. That's a lot of states. and each of them has its own animation or some single static frame that is rendered, some very custom properties like your maximum speed while you are crawling is different than the one while you are walking, or the running speed. While you are exiting a level or you are dead or either stunned, you can't possibly start running or ducking, so the input must be ignored. While you are jumping, you can't jump again while you are flying. You can't initiate pushing a wall while you have no collision from the bottom, while you are not standing on anything and you have no collision from either left or right side. So you have to be in walking or standing or running state to start pushing a wall. And not going into the rabbit hole, containing all this mess can be solved by, for example, I don't know, using an emulator, listing all those possible states and having a gigantic switch ladder in your codebase. But it is still a mess. What you need is a state pattern, because it will separate all the logics, all the properties that have some logical value only in context of this specific state. So how exactly do you implement this state pattern? Well, firstly, you need a base state. The base state will define an interface that will be used in all the specializations. In case of MainDude, it will be called a MainDude base state, and it contains an update method returning back the pointer to the base state, and it takes a reference to the MainDude object. It also takes delta time. This is very custom, depending on what you are writing. If you are writing a game, you'll probably want to pass a delta time of the last frame. It also defines handle input method. Again, very same logics, but specifically for handling input. And the enter function is the function that is called only once on entering this specific state. So let's have a look at the MainDude. MainDude contains a struct with all the possible states and a pointer to the current state. So if you are changing state, you are returning from the update or handle input methods a pointer to one of those. So let's inspect some state. Let it be MainDude standing state. It has a member that has some logical meaning only in this state specifically, and it is X collision timer. X collision timer is accumulated with delta time only when there's some collision from the left or right side, and if it reaches some value, the pushing wall animation end state will be entered. So it stops already started animation on entering and sets a static frame, being the stand left. So that was the enter method. The update method is called while you are still in this state. So it updates components, the physics component, the quad component, and has the other logics. And the other logics is, if the velocity is non-zero, change the state to running, so it returns a pointer to the states running. If the velocity on the vertical scale is bigger than 0, then he's falling, then jumping. In case of left or right collision, the X collision timer is accumulated, and if it reaches 400 milliseconds, then it enters pushing state. And if he did not enter any other state so far, return pointer to the current state. But how exactly this pointer transitioning happens? Well, MainDude is a specialization of a game object. Each game object must override an update method. The game loop contains an array of pointers to the game objects, And depending on the state of the game loop, because it is also divided into states, let's say game loop main menu state. In the game loop main menu state, each of those objects is updated. If, for example, this object was a snake and the snake was killed, it probably marked itself for disposal, and in that case it is removed from this list. But getting back to the main dude, his update method is update some generic properties that are valid for each state, handle input, and what's most important, it assigns a pointer to the new state from state's current update. If the new state is different from the current state, then enter the new state and replace current state with the new state. Let's see all the states that the game loop can take. It can be either main menu state, playing state, started state, which is entered only once in the full game lifespan, level summary state, and there is also a pointer to the current state. So let's inspect the started state, which is called only once, as I said. Let's see the enter method. There are some camera calculate coefficients methods called, which are dependent on the screen resolution, and there is load textures and textures regions methods. So again, things that need to be called only once, and there are some level generator methods called to generate cave background and so on. It also sets the game initialize method to be true, so to exit the state immediately after entering. Let's inspect the main menu state. So on enter, it cleans the map layout, it initializes the map layout from the main menu, it batches vertices, sets camera position to fit the main menu level on the screen, it adds all the possible sprites that are needed, like the main logo, start sign, scores sign, tutorial sign, assigns positions, and also adds the main dude. They are all added to the game objects array. On exits, it cleans the array, it removes the text buffer, removing all the possible text that is added, and in the update method, it goes over each of those objects, calling their consecutive update methods, removes the objects that are marked to be removed, and there is some custom logic, like if the main dude entered door, then it goes to the playing state. Font rendering is a thing that we are used to take for granted. You don't go around Unity thinking how do you make text appear on the screen. However, when you're writing a game from scratch in OpenGL, this is a problem that you need to solve. You can either pick a technology like TrueType, where your font will be stored in mathematical functions, or actually store fonts like images. There will be an obvious drawback, because the quality loss when you are scaling your fonts up will be dramatic, but in case of font like the one in Spelunky, where it is monospace, it is pixel art, it is nearest filtered, there will be no quality loss. So I decided to store fonts as images, but how exactly do you store images in Spelunky PSP? Well, here's a quick recap of what I explained in the previous episode. Let's say that you want to pack all the animation frames of the main dude. They are stored in some directory and they are named from 0 to 68, where 68 is just the last animation frame. Each of those frames has a name corresponding to the enumerator called main.dude spritesheet frames. Run left first has an index of 0, and the first tile with 0.png file name stores the first frame of animation of running to the left side. So you can see the relation between the file names of each frame to the enumerator. And this is how I do in each tile sheet, in each sprite sheet. You have this 0.png with an arrow, so let's see H3D sprite sheet frames, and the first element of this enumerator is an arrow icon, and it has an index of 0. I do the same for font. And then, what I do with all those frames, I use a third-party software called Atlas C to gather all those possible tiles, all those possible frames, and pack them into a single texture, into a single entity. What Atlas C also outputs is a JSON file which describes all the possible texture regions. It describes U and Vs that you can use then to sample a specific subregion of this texture. What I do then with those two files is pass them to the resource compiler. It is a simple program that I wrote that loads past files, and for each byte of those files it outputs a header file defining an array where each byte is defined in this array. So for the PNG file and the JSON file, they are then outputted as two HPP files that I then include into Spelunky PSP. So there's this font.json HPP, for example, and I have this texture bank class, which is just an abstraction that I invented for this specific job of loading textures and loading texture regions. Loading textures just uploads those textures to the GPU via OpenGL calls, because now in this texture bank I have an access to char pointers to those images, and texture regions loads the JSONs. It parses them and stores the UVs that can be later used. And they are used in the getRegion function. To get region, the texture region stores U and Vs. To get region that you are interested in, you pass a texture type, which can be either cave level, tiles, main dude, main menu, HUD or font, and they correspond to those bundled sprite sheets. And you pass an index. Index is an integer corresponding to a specific sprite sheet tile that you can take from this sprite sheet frames enumerator. Another thing that you need to take into consideration when writing a font renderer is having a screen space camera. Now, I won't get into the details of how cameras works, but the most prominent types of cameras that you will encounter is screen space camera and model view camera. Model view camera is the camera that, in example of this 3D cube, will take into consideration the cube's position and rotation. Then it will take into consideration camera's own position and its rotation, and that will make a view matrix, and then a projection matrix will be applied, and this is again related to the camera. Projection matrix contains describes the frustum of the camera, which is aspect ratio, field of view, and only then the image is finally transformed to clipping space and screen space. In the screen space camera, you only have those two last points, so things are rendered where you place them. In most of the screen space cameras, this will be described in pixels directly. And in Spelunky PSP, I have those two types of cameras. I have the screen space camera and model view camera, and I apply them in the playing state. I firstly apply model view matrix and projection matrix to the OpenGL, and then render model view space entities. Then the screen space camera updates its model view matrix and projection matrix, and I render only screen space entities. The last thing that needs to be done to implement a font render will be to actually define an interface. So I created this text buffer, and it is also a game object, so I can push it to the game objects array and the game loop will update it for me and I can forget about it. It also defines this create text method, remove text, and update text. Creating text returns an ID that can later be used to remove or update text. So updating text involves passing the ID, position, and contents, which is a char pointer. I explicitly wanted to make it as easy as using print or cout in the standard library. So, you may be familiar with the term of ASCII table. ASCII table defines how exactly do you encode symbols from the alphabet as numbers in your char data type. So, for example, if you wanted to store a capital O in your char, you would assign a 79 decimal value to it. So, for each of those chars, I wanted to match it with a frame from my sprite sheet. As you remember, my sprite sheets start from 0, and it so happens that they are ordered in the same order as the ASCII table symbols, because I ordered them. But thing is, I need to add 32 so they would match to the ASCII table exactly. So the space starts from 0, but after adding 32, it will be 32. So space 32, that's small. It matches. And the text buffer, it creates an index from the number value of the char and adds an offset, and then matches it with the frame from the sprite sheet. For some time I involved into upstreaming my changes into the PSP toolchain. For example, I wrote a cmake macro for creating a PBP file from an executable. This was later accepted and pulled into the master branch of the PSP toolchain. I also helped with upgrading the bundled GCC into a more recent version, so right now you can try C++20 experimental features on your 2005 console. There are still loads of work to be done, especially considering how many different NPCs there are, and there's still loot to be added and different levels, not only the cave level, but also the jungle level, the Yeti level, the lava city level, not mentioning the final boss. But I'm happy that the initial effort that I put into setting up the project has paid off, and it actually gets easier as the development progresses. The next thing that I'll probably take on will be fixing this hanging off cliffs behavior and possibly migration to SDL2, as I'm really worried by the screen getting darker when the camera moves. I think that it has something to do with the custom code that the SDL for the PSP contains. Also, some pausing the game and exiting the game would be nice. And that being said, thanks for watching and see you next time.